In our previous video, we were exploring how we standardize a potentiometer, and we explicitly said that standardizing a potentiometer is the process of finding the PD per unit length of a potentiometer wire, or the PD per unit length of a potentiometer. When we find the PD per unit length of a potentiometer, we are able to just simply tell the potential difference across a portion of the wire by multiplying that length of that portion of that wire by the PD per unit length. So in this video, we are going to explore how we measure the potential difference of this resistor using a potentiometer wire. Now, if you look at this potentiometer, of course, we have the driver cell, these two switches K1 and K2. K1, if we are to close that K1, it means that we are putting this driver cell to release current into the primary circuit, and then these two also. And then K2 also brings this other cell 2 into the circuit. So as we start the illustration of this experiment, it is under the assumption that we have finished standardizing our potentiometer. So after standardizing our potentiometer, and now we are aware of the PD per unit length of this potentiometer wire, we will go ahead and connect it as shown below. So after connecting our potentiometer circuit as shown, we shall close switch K1 and switch K2. And after closing these two switches, this galvanometer will deflect. So we shall move this sliding jockey along this potentiometer wire, and we shall stop at a point where this galvanometer shows no deflection. When the galvanometer shows no deflection, it means there is no current going through the galvanometer, and therefore there is no current going through the secondary circuit. So when the galvanometer is showing no deflection at that balance point, let's say the balance point is B, the potential difference across the portion of that wire AB will be equal to the potential difference across the components in the entire circuit. So here it means that when we get the potential difference across the portion of the slide wire that has between the point A and the balance point B, the potential difference across that portion will be equal to the potential difference across this resistor. Remember, here we are interested in finding the PD using the potentiometer, and in this case the PD we are interested in finding in this is this one. We want to find the potential difference across this cell. So after closing those switches K1 and K2, and then we slide this jockey and we obtain a point where there is no deflection, we will go ahead and write our calculation that the potential difference across the components in the secondary circuit, which include that resistor whose potential difference we are interested in finding, is equal to the potential difference across the balance length AB. And since this is already a potentiometer whose PD per unit length we know, K, it means that that potential difference we're looking for, V, is going to be equal to K times the balance length L, which so happens to be AB, or we can call it LAB. Now, of course, K is going to be equal to the value of K, like in our previous video, is the standard cell we used. Divide that by the balance length that is corresponding to the standard cell. Now, this is coming from our previous video when we were finding the value of K, which is the PD per unit length of the potentiometer wire. And this is definitely how we will always be finding the potential difference across the elements in the secondary circuit. It's a matter of finding the balance point. When the galvanometer is not deflecting, then we get the balance length. And after getting the balance length, the principle here is that the potential difference across the balance length is equal to the potential difference across whatever is in the secondary circuit. And then we proceed on and on with our calculations. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia, helping you manifest excellence.